So the last time we were together, we solved matrix equations, okay? The step to solving a matrix equation, you really need to know how to find the what of a matrix. Starts with an I, the inverse. And to find the inverse, you had to know how to find the determinant. And we only did that with 2 by 2 matrices. So what we're going to do, I mean, the lesson today incrementally is not that much. It's like, it's like going one step further upstream, okay? So let's look at, this is a matrix equation right here, okay? You know immediately to solve that, xy is going to be equal to what? The inverse of that first matrix times 3, 7. So that's how you solve that first problem. The inverse of this square matrix times 3, 7. Okay. Now, let's just back up over a second and see. Let's look at right here. This is the left side of that equation. Here's the right side of that equation. Let's multiply this out. So this is a what, 2 by 2 matrix? What's the next matrix you see? A 2 by 1? So I can multiply those and I will get what? A 2 by 1 matrix. So when I multiply these two matrices together, so let's put a little extra space. When I multiply these two matrices, I get what? 5x minus 7y. Okay. And then I get 2x plus 3y equal, and what was the other side of that matrix? What, 3, 7? Okay. Now, you probably were used to seeing things like this in algebra. What if I just wrote it without the brackets? You know that 5x minus 7y has to equal 3. 2x plus 3y has to equal 7. Okay? You saw this a lot in Algebra 1, hopefully. This is just a system of two equations. Okay? You solved this graphically. How else did you solve it? Do I need to send y'all back across the street? Okay. How else did you solve this thing? What was it? Not replacing with 0. Well, you could. What? Substitution. Okay, you solve one for one of the variables, substituting the other equation, and the other one was called elimination. Okay, so you had multiple ways of solving this or graphing these. Okay, when we get to the next unit, unit 2, there'll be a lot of equations like this that show up, and we'll be doing things graphically. So what we're really saying is, if you ever see something like this, 5x minus 7y equal 3, 2x plus 3y equals 7, you can just write that as a matrix equation. Okay, so I can say, let's write this as a matrix equation and solve it. So all you have to do is you pull all the coefficients. So 5, negative 7, 2, 3. And then you write your variables. My variables are x and y. And then what's the solution on the other side? 3 and 7. You can rewrite that system of equations as a matrix equation. And then we know how to solve this because that's what we did the last time we were together. So to solve this guy, how do we solve something like this? We know that xy is equal to the inverse of this matrix times 3, 7. So to find the inverse of that matrix, first I need to find the determinant. And the determinant is going to be what? 5 times 3 minus 2 times negative 7. So that's 15 plus 14, which is 29. So the determinant is 29. So that tells me that this is, what, 1 over 29. And what's the next matrix that I write down? The 3 and the 5 change places, right? And then what happens to the 2 and negative 7? They change their signs. So negative 2, positive 7, all of that times 3, 7. That 29, I'm holding that out for my last step, right? So this is 1 over 29. And now let's multiply. What is 3 times 3? 9. What is 7 times 7? Yeah, so this is 9 plus 49. And this is negative 6 plus 30. Is that right? It should be. No. Negative 6 plus 35. Negative 6 plus 35. So this is what? 1 over 29. 49 plus 9 is 57. Right? Oh, darn. It's not 57, it's 58. And this is 29. What is 58 divided by 29? Everyone said 2. I just didn't hear them. Okay. What is 29 divided by 9? That is 1. The answer to this problem is x equal 2, y equal 1. Okay. So once I got to here, this was yesterday's problem. All we're saying is when you see a system of equations, you can rewrite it as a matrix equation. So when you encounter anything that looks like this, you're going to build it as a matrix equation. You take all the coefficients, A, B, D, and E. You have the variables x and y, and then you have the solution matrix over here, C and F. So this first matrix, that's my matrix of coefficients. X, Y is the variable matrix, and CF is the solution matrix. So you can rewrite a system of equations as a matrix equation. And then once you get it as a matrix equation, you know how to solve it by taking the inverse. So let's work a few examples before I turn you loose for the day. Rewrite this as a matrix equation. So to rewrite this as a matrix equation, what is going to be the matrix of coefficients? You know what? Negative 2, 3, and then what? 5, 1. What's the variable matrix? X, Y. And the solution matrix is negative 11, 19. Okay. So really, I mean, this is the only new part, is going from here to here, because this would be a problem you would have seen yesterday. Okay. So now to solve this for xy, xy equal what? What goes next? The inverse of the coefficients times negative 11, 19. So to find the inverse, I must first find the determinant. And that's going to be what? Negative 2 times 1 minus 5 times 3. So that's negative 2 minus 15, which is negative 17. So this tells me that xy equal negative 1 over 17. And then what matrix goes next? You flip the 1 in negative 2. And then I'm going to have what? A negative 5 and a negative 3. All of that times negative 11, 19. So negative 1/17. And then let's do the multiplication. What is 1 times negative 11? Negative 11. So negative 11. What is negative 3 times 19? Negative 57. And you can rely on a calculator if you need that. What is negative 5 times negative 11? 55. And then what is negative 2 times 19 minus 38? So this is negative 1/17. Negative 11 minus 57 is negative 68. 55 minus 38 is, what is that, 17. And what is negative 68 divided by negative 17? 4. Okay, so this is just, and what is 17 divided by negative 17? Negative 1. So here x is equal to 4, and y is equal to negative 1. Okay? So this shouldn't feel too much different than what we saw before. Let's do a couple more, then I think I can turn you loose on this one for the day. Matrix equation. So to write it as a matrix equation, first you extract what? All the coefficients, 4 and 5, 5 and negative 1. Then you have your variables, x, y, 23, 7. Go there. So x, y is the inverse of this matrix times 23, 7. And then we have to find the determinant. So the determinant is going to be 4 times negative 1 minus 5 times 5. So that's negative 4 minus 25, which is negative 4 times minus 25, negative 29. Right? Negative 4 minus 25, negative 29. So this is xy equal negative 1, 29. And then the adjoint matrix times 23, 7. So I've got negative 1 over 29. So what is negative 1 times 23 is negative 23. Negative 5 times 7 is minus 35. Go to the second row. Negative 5 times 23 is negative 115. And then 4 times 7 is 28. So to continue this work, let's see what we get. Negative 23 minus 35 is negative 58. And 15, that's going to be what, negative 87. What is negative 58 divided by negative 29? 2. So this is 2. And negative 87 divided by negative 29 is 3. So x is 2, y is 3. So you guys take a look. When you rewrite this as the matrix equation, 3, 7, 9, 21, you're going to need to find the inverse of that matrix. So 3, 7, 921 inverse, then you're going to go find the determinant. The determinant is 3 times 21 minus 9 times 7, which is 63 minus 63, which is 0. Okay. If the determinant is 0, the inverse is undefined. If the inverse is undefined, what is the solution to this set of equations? Yeah, so I would take two answers for here. I would take undefined, or I would take the words no solution. Okay, either one of those. Okay, so you're done when you get to that one. Okay. So what I want to do, I think you guys have sufficiently done a 2 by 2. I'm going to skip this 2 by 2 and let's work on this 3 by 3 here. Okay. Now, I'm not going to make you go through it by hand, but the setup is the same. So how do I write this as a matrix equation? What are the coefficients? 1, 2, 1, and then what? 2 minus 3, 7. 1 minus 1 minus 4. That's my coefficient matrix. Okay. What's my variable matrix? X, Y, Z. Okay. What's my solution matrix? 4, 4, 7. Okay. So nothing changed from a 2 by 2 by 3 by 3 at this point. The equation is the same. And the next step is going to be the same. X, Y, Z will equal what? The inverse of that 3 by 3 matrix times 4, 4, 7. Now, that's all. Nothing has changed there. It's just a little bit extra writing. But here's the deal: you don't know how to find the inverse of a 3 by 3. That's what we're going to spend a lot of time on Monday. But let me just show you real quick. It's not going to be too hard. So, what you can do, and we'll go over this in detail. And this is why you really need your calculator with you. So, matrix. I need to create a matrix. And this matrix needs to be a 3 by 3 matrix. And the suspense is not there because I've done it up there. So you'll be typing in, well, 1, 2, 1, 2, negative 3, 7, 1, negative 1, negative 4. And then, but what do I need of that matrix? I need its what? Inverse. So what you'll do is you'll have to find the, so I raise it to the negative 1 like that. That's the inverse, okay? And then I need to do what with that? I need to multiply it by what? The next matrix. So the next matrix is menu, matrix and vector, create a matrix. What size matrix is the next one? Yeah, it's a 3 by 1. And that matrix has, what is it, 4, 4, 7, and then just hit enter and I'm done. Okay, so there is the solution for that. Okay. So you should love a 3 by 3 because you get to use the calculator on it. Okay, this would be a heck of a lot of work if you had to do this one on your own. So that's what I mean when the calculator section, it's going to have harder problems, but you know, this is not that hard when you've got the calculator. Okay, you just have to know the commands, how to enter matrices, how to navigate, because sometimes the calculator can be a little bit clumsy. Okay.